So as we mentioned, there is no need to predict the exact time of the earthquake. We know the areas where the earthquake is going to happen, where prone to earthquake. We know the type of the buildings that are prone to damage, and we can even the existing building that were designed many years ago before the advanced earthquake design provisions were available. We can update them. We can cope with the earthquake and live with the earthquake. We can design new buildings so that they can perform in any way that we want. We can isolate them, for example, like a couple of hospitals that during the Turkey earthquake continue to provide the function. We can isolate them, basically remove them from the ground and put them, imagine, like on a spring. Basically, the ground is moving, but the building is not moving, and the content is not going to get damaged. So we can use the base isolation. If it's a very tall building, because it has to be attached solidly to the ground, we can put a very heavyweight pendulum at the top of the building, actually, that moves in an opposite direction of the motion that is generated by the earthquakes. Some of the old buildings, for example, the Utah State Capitol that I know in the US, that was designed many years ago, and it was placed on the base isolation. Usually when the footprint of the building is very large, so it's like a rectangular, very large footprint, usually the base isolation is much better. For the taller buildings, the pendulum is better. One of the very interesting concepts is a pagoda, P-A-G-O-D-A, pagoda type buildings. These are timber buildings in Japan, and many of them were constructed hundreds of years ago and have stood these forces. So in the center of these multi-story buildings, there are these basically a column that basically limits the movement of each floor, and each floor actually are separated. And I will argue, actually, I was the other day I was looking at it. This concept of the base isolation that we talk about, I think goes back to the pagoda. Basically, in the case of the pagoda, every floor is isolated from the rest of it, and then this column that's in the center of the building, it kind of controls the overall movement of the building. So this concept of base isolation, in my opinion, I mean, I could be wrong, but I think there are lots of similarities between the base isolation that we use, the concept that was used hundreds of years ago by the Japanese, basically in the building. And this concept, actually, one of the very tall Tokyo Sky Tree, I believe the name is, that have used the same concept to resist the forces of the earthquake, except that instead of the timber column in the middle, they've used the concrete, and they have added some additional, basically, control system. So in summary, really, we have many tools that are available to us. We have the ability to, based on the P wave, the initial wave that comes, we have the capability of giving a 5-10 second, depending on where you are at, up to even a 1 minute warning that the earthquake is coming. And that is enough to shut down the electricity, the gas lines, give warning to the people. And that's a direction of the research in some countries. And some countries like Japan, for example, has the most sophisticated earthquake warning system. So there are many tools that we have in our disposal in order to cope with the earthquake and live with it. And there is no need to predict the exact time of that. At least in my lifetime, I don't believe. In the science and engineering, one thing I have learned is that never say never. like I said, there's no need for it because we have to make sure that our constructed facilities, our cities are resilient against the earthquake, and that's really where the concentration should be.